Last week during a scrum call, the DevOps engineer mentioned he forgot to format his Packer code before pushing. You know what he said? Hey, I'll go back and fix it manually now. I've been there. We've all been there. But here's the thing. This happens every day. Every stand-up between dev teams, DevSecOps engineers, SRE folks, platform engineering teams, someone catches something that should have been automated. And how we handle these moments, that's what separates chaos from excellence. So instead of just saying, no worries, fix it manually, we took it to the Slack channel after the call. I shared some code examples I had. He took those, created pre-commit hooks for GitLab, added a CI check to check to catch it before merge requests. Problem solved. Not just for him, for everyone, forever. Release this. That's platform engineering. That's thinking like Google SRE teaches us, eliminating toil. Always asking yourself, is this something I should automate so I will never have to do it manually again? And here's where it gets more interesting. This isn't just about code formatting anymore. We're in an era now where AI agents are throughout the entire software development lifecycle, not just GitHub Copilot helping devs write code. We're talking AI-enhanced secure SDLC from start to finish. This is Faith, Freedom, and Tech. I'm Scott Oak, and today we're talking about platform engineering, the evolution from DevOps to DevSecOps to SRE to this next level. We're building platforms that make the right way the easy way. First off, I want to apologize for not getting this episode out on Tuesday like I normally do. As many of you know, I'm a disabled veteran, and I, from time to time, get some pretty bad migraines from some toxic chemical exposure on the USS Ashland. You know, there was good parts of the Navy, and there's some other parts. But, you know, a lot of guys have it a lot worse off than me, so I'll take some migraines occasionally that I got to fight through. But here we are, getting the episode out. So, welcome back to Faith, Freedom, and Tech. If you've been following the series, you know we've been building something here. A comprehensive DevSecOps foundation. We're starting with DevSecOps principles and discipline in episode 2, then Kubernetes orchestration in episode 4, bringing that to a systematic thinking container management. Now, last week, episode 6, multi-cloud architecture, building bridges between AWS, Azure, and GCP. I've seen a lot of questions about this all over social media. Multi-cloud is not what people always think it is. And, you know, even designing the cloud is not what a lot of people that work in organizations and not in consulting think it is. It's not as cut and dry. Customers don't always do the smart choice. But as consultants, all we really can do is guide our customers the best we can, show them the solutions that we think is the best, and when they don't take it, get sign off as to why. Let's be honest, we'll cover our own asses. But let's dive into it. So all of that has been leading us here to platform engineering, because this is how you actually implement all of that stuff at scale. This is the difference between one team doing cool things and an entire organization moving fast without breaking things. Now, for those of you just joining us, quick context. I'm Scott Houghton, been in tech over 20 years, started programming at 11, self-taught, spent 4 years in the Navy, a few years aboard the USS Ashland as an engineman. I've worked at Google's PSO, AWS as ProServe, consulted with McKinsey, PwC, Deloitte, many other companies. I've built these platform engineering solutions across Fortune 500 companies in all three major clouds. And I got to tell you, this is something I've been writing about on my Medium articles. I wrote a 12-part series called Crafting the Modern IT Ecosystems. Parts 3, 4, and 11 specifically deep dive into SRE, platform engineering, and how it all comes together. We're going to pull from that today because that's real implementation experience, not theory. So let's talk about how we're actually doing this. Let me paint you a picture here of where we are. Traditional DevOps, circa 2015, through maybe 2020, every development team has their own DevOps engineer. Or worse, which is what a lot of organizations did, developers are supposed to own operations, which happens great in theory, but in practice, it means developers are doing two jobs poorly instead of one job well. Here's what that looked like. Developers spending maybe 40% of their time on infrastructure, not features, not solving business problems, fighting with YAML files, debugging Terraform configs, figuring out why their Kubernetes pod won't start. Every team reinventing the wheel. Different versions of Kubernetes across teams, different CI/CD pipelines. Some use Jenkins, some use GitLab CI, some using GitHub Actions. Different security scanning tools, no standardization, no reusability, complete chaos. And the DevOps engineers, they're buried, ticket after ticket. Can you help me debug this Terraform? Why isn't my pod starting? How do I configure this load balancer? They're becoming bottlenecks instead of force multipliers. Now, I saw this well, let me keep this general for legal reasons, but a major financial services company. They had about 200 development teams, each team supposedly doing DevOps. But what they actually had was 200 different ways of deploying applications, 200 different security configurations, 200 different monitoring setups. When we did an audit, some teams were running Kubernetes 1.18, others 1.24. Some using Jenkins, some GitLab CI, some had vulnerability scanning. Most didn't. It was a nightmare. And here's what really got me. The developers hated it. They didn't want to be infrastructure experts. They wanted to write code, ship features, solve business problems. But instead, they're spending half their time fighting with infrastructure. The operations team hated it too because they couldn't scale. They couldn't provide consistent security. Every request was bespoke. Every deployment was a special snowflake. This is what I call the DevOps plateau. You've adopted DevOps. You've broken down silos. You're automating some stuff. But you've hit a wall. You can't scale further without things getting exponentially more complex and expensive. And that's where platform engineering comes in. So what is platform engineering? It's the evolution of DevOps. Instead of every team doing their own operations, you build a platform, an internal developer platform, and you make infrastructure self-service. Now, here's how I explained this in part 4 of my Medium series. Platform engineering is about creating and maintaining the paved road for developers. You build common services and tools, container orchestration, CI/CD pipelines, logging, monitoring frameworks. Each development squad doesn't have to reinvent the wheel. The goal? free up developers to focus on delivering business value rather than wrangling infrastructure. Think of it like this. In the early days of computing, if you wanted to run a program, you had to understand the hardware, configure memory, manage disk I/O, handle interrupts. Then operating systems came along. Windows, Linux, Mac OS. They abstracted all that complexity, gave you APIs, gave you a platform. Suddenly, developers could focus on applications instead of hardware management. Platform engineering does this same thing for cloud infrastructure. Now, the formal definition. I'm pulling this from the series. Platform engineering is the discipline of designing and building tool chains and workflows that enable self-service capabilities for software engineering organizations in the cloud-native era. Now, let me break that down in plain English. You're building a platform internal to your company that gives developers self-service access to infrastructure with guardrails, with best practices baked in, with security and compliance automated. Here's what this looks like in the modern IT ecosystem. And for those of you that'd like to read the series, this comes from part 1 and part 11 of that series. You've got these 3 disciplines working together. DevOps focuses on speed of delivery. DevSecOps integrates security. SREs handle reliability and eliminating toil. Platform engineering, it's the foundation all 3 need. And here's what's critical. This isn't replacing your operations team. It's elevating them. Instead of being ticket takers, they're becoming platform builders. Instead of doing repetitive work, they're building systems that automate that work. The core components, this is straight from part 4. Infrastructure as code using Terraform or OpenTofu. Container orchestration, usually Kubernetes. Standardized CI/CD pipelines. Observability baked in from day one. Secrets management, automated. But here's what platform engineering is not. It is not just Kubernetes. It is not just CI/CD. It is not just infrastructure as code. It's all of those things integrated, abstractive, and made self-service. And the key word there is self-service with guardrails. So let's talk about what we call golden paths or the paved road. This is critical to understanding platform engineering. Golden paths are recommended ways to do common tasks. The happy paths. Deploy a web app. There's a golden path. Set up a database. Golden path. Create a CI/CD pipeline. Golden path. Now, going back to the Packer story at the beginning of our show, that's a perfect example of how golden paths get built. Our DevOps engineer forgot to format his code. Could have just fixed it manually and moved on. But instead, we took a step back and we thought about it. This is going to happen again. Someone else is going to make the same mistake. So I would make it impossible to make that mistake. We automate it. Pre-commit hooks that format your code before it even leaves your machine. Site checks that catch it before merge requests. Now, it's not about remembering to format your code. The platform now does that for you. And this is where Google SRE principles come in. One of the core concepts from the SRE book is eliminating toil. Toil is work that's repetitive, manual, automatable, lacks lasting value. Every time you catch something in a stand-up that could be automated, that's toil. And platform engineering is about systematically eliminating the toil. If you're doing something manual more than twice, you should be asking, can I automate this? Can I build it into the platform? Can I make it impossible to do it wrong? That's the mind shift from, I'll fix this manually, to, how do I make sure no one ever has to fix this manually again? Now, self-service with guardrails. This is important. Self-service doesn't mean developers can do whatever they want. It means they can provision what they need when they need it within the boundaries you decide. You want to deploy a new service? Cool. The platform gives you compute, storage, networking, monitoring, security scanning, all configured according to your organization's standards, all compliant with your policies. You don't get to deploy a service with SSH open to the internet. You don't get to skip security scanning. You don't get to ignore monitoring. The platform enforces this thematically. That's self-service with guardrails. Now, if you remember back to episode 6, where we talked about multi-cloud, platform engineering is what makes multi-cloud actually practical. Here's how this works. You create abstractions. Instead of developers saying, deploy to AWS, they say, deploy to the cloud. The platform decides based on cost, capacity, and compliance requirements. And this isn't going to work for every scenario. And it takes a long time to figure out how to do that. Not every organization is going to be good at that. But the ideas can apply to most organizations. Same thing with databases. Developer says, I need a Postgres database. Platform provisions it. Might be Amazon RDS, might be Azure Database for PostgreSQL, might be Cloud SQL on GCP, wherever it makes sense for that platform. And the system should be smart enough to be able to figure that out. Developer doesn't care. They just get a connection string that works. This is how you do multi-cloud without it being chaos. You abstract the differences. You make platforms handle the complexity. And this is where those patterns from episode 6 come in. Remember, we talked about disaster recovery in multi-cloud, primary in AWS, DR in Azure. Platform engineering makes that operational. And again, just to respond to the many comments of people who don't like that idea, there are practical reasons for this. Sometimes it makes sense to not do everything in AWS just because you, as an architect, prefer AWS because you didn't bother to learn anything else. Multi-cloud is more than just what your ideas are. It's an organizational decision. And as an engineer or an architect, you should always be pushing your bounds and living by the DevOps and DevSecOps principles, continuous learning and the feedback loop. If you find that you're, resistant to change, adapt and overcome. That is a principle that will never leave me from my military days. Adapt and overcome. The only easy day was yesterday. So now your deployment pipeline knows how to build a deploy to both clouds. Your observability stack collects metrics from both. Your incident response runbooks work across both. The platform handles the multi-cloud complexity, so your developers don't have to. So, all right, here's where this gets in really interesting. This is not just about platform engineering anymore. We're talking about AI-enhanced secure software development lifecycle. And this is where it goes way beyond GitHub Copilot helping you write some code. We're talking about AI agents throughout the entire SDLC. Code generation with built-in security scan. AI-powered threat modeling that happens automatically. Intelligent pipeline optimization that learns from your patterns. Predictive scaling based on historical data. Let me give you an example of what this looks like. You're writing code. Your AI coding assistant, be it GitHub Copilot, could be Person, could be Claude, be Claude. It's helping you write that code. But here's what's different now. As you're writing, it's also checking that code against your organizational security policy. It's checking for vulnerability dependencies. It's suggesting more secure patterns. You commit your code, your CI pipeline kicks in, but it's not just running static tests. AI is analyzing your code for patterns that have caused production issues before. It's predicting which tests are likely to catch bugs based on what you've changed. You deploy to staging. AI is monitoring the deployment. It's comparing performance patterns to previous deployments. If something looks off, it alerts you before it even hit production. That's AI-enhanced SDLC. And platform engineering is what makes this possible at scale. Now, going back to that Packer formatting story, what started as a manual process, remember to format your code, became automated through pre-commit hooks and CI checks. But we can take it further. Imagine your AI coding assistant knows your organization's formatting standards. It formats your code as you write. It suggests better patterns based on your internal style guides. That's where we're heading. Not just automating the checks, augmenting the entire development process with intelligence. So how do you actually build this? Let me give you the real implementation. This comes from part 4 of the series and from, honestly, dozens of implementations I've done. First principle, start small. One golden path, one pilot team. Don't try to boil the ocean. Pick the most common use case. Maybe it's deploying a containerized web application. Build that golden path really well. Make it so good that your pilot team loves it. Then expand. Second principle, developer-centric approach. Your developers are your customers. If they don't want to use your platform, they won't. And they'll build shadow IT around you. So you involve them from day one. What are their pain points? What would make their lives easier? Build that. Third principle, progressive enhancement. And this is critical. You can't drop all these checks and requirements on a team at once. Here's the progression I recommend. And I laid this out in the DevSecOps automation article I wrote. Phase 1, format and validate. Week 1, just get the basics working. Formatting checks, validation. This alone catches 60% of errors. Phase 2, security scanning. Weeks 2 through 3. Add tools like checkoff or TFSec. Start in the warning mode. Let teams fix the initial findings and then make it blocking. Phase 3, policy as code. Weeks 4 and beyond. Implement open policy agent or similar. Enforce actual policies. This gradual approach is important. It gives teams time to adjust. It builds trust. It shows value incrementally. Now, common mistakes, because everyone makes these. Let me help you avoid them. Mistake 1, over-engineering early. You want to support every language, every framework, every development pattern, every cloud service. You end up with a platform that does everything badly instead of a few things really well. I've been guilty of this before. The solution? Start narrow. One language, one framework, one deployment pattern. Make that perfect. Then expand. Mistake 2, build it without user input. You build this amazing platform. Nobody uses it, right? Because you didn't involve users in the design. You built what you thought they needed, not what they actually needed. Solution? User research, pilot teams, continuous feedback, built with your users, not for them. Mistake 3, no documentation. A well-built platform is useless if teams don't know how to use it. Solution? Documentation is part of the platform, not an afterthought. Mistake 4, mandates instead of empathy. You force teams onto the platform without considering their needs. That backfires, leads to shadow IT, custom pipelines built around your platform. Solution? Show value. Make the platform so good they want to use it. Migration should feel like an upgrade, not a punishment. Now, let's talk about how organizations matured through this. This comes from part 2 of the series, where I laid out the DevSecOps maturity model, as I call it. Level 1 and 2, initial and managed. Platform engineering is minimal or non-existent. Operations handles incidents manually. You've got basic pipelines, but they're inconsistent. Level 3, defined. A standardized platform emerges. You've got repeatable CI/CD patterns. Environmental setups are consistent. Security tools starting integrating into pipelines. This is where most organizations should aim to hit first. Level 4, quantitatively managed. Metrics and feedback loops refine the platform continuously. Security and reliability, data-driven platform evolution. You're making data-driven decisions about what's next to build. Level 5, optimizing. The platform is fully realized self-service product. AI and machine learning help with workload scheduling, predictive scaling, proactive security scanning. And here's how DevOps, DevSecOps, SRE, and platform engineering work together at each level. DevOps culture enables platform engineering. You need that collaborative mindset, that breaking down of silos before you can build effective platforms. DevSecOps bakes security into the platform. Security isn't bolt-on. It's built from day one. SREs eliminate toil throughout the platform. All those repetitive manual tasks, they're getting automated and standardized at the platform level. Platform engineering makes all 3 scale. It's the force multiplier that lets you go from one team being effective to hundreds of teams being effective. Let me get you a real life example. And I'm going to keep this general, but this pattern I've seen work multiple times. Organizations with about 150 developers, multiple teams, building microservices before platform engineering. Each team was doing their own thing, taking 2 weeks to deploy a new service. 2 weeks, request infrastructure, wait for approval, provision, configure monitoring, set up CI/CD, configure security scanning, all manual, all slow. This took about 4 months. After building a platform, same development, takes 20 minutes. Developer logs into the internal developer portal, clicks new service, fills out a form, selects language and framework. Boom. Infrastructure provisioned. CI/CD pipeline created. Monitoring configured. Security scanning enabled. DNS setup. Everything. That's a 97% reduction in deployment time. But here's what's more important. It's not just faster, it's consistent. Every service gets the same security scan, same monitoring, same compliance checks. And when we need to improve something, let's say we want to add a new security scan, we add it to the platform once. Now, every service gets it. Automatic. That's the power of platform engineering. You solve problems once at the platform level, and everyone benefits. You know, this concept reminds me of something from my time in the Navy. On the USS Ashland, we didn't have every sailor building their own tools. We didn't have every division creating their own procedures for everything. We had EOS, the Engineering Operational Sequencing System. Standard operating procedures, damage control procedures, these were our platforms. When I stood engine room watch, I didn't have to figure out how to start the main engines from scratch every time. There was a procedure, a golden path. Start with lube oil systems, refuel them, then combustion air, step by step, proven, safe, effective. That's platform engineering. You're building the standard operating procedures, the proven paths, so your developers can focus on the mission, building features that serve users instead of fighting with infrastructure. From a faith perspective, there's something in Proverbs chapter 24, verse 27 that applies here. Prepare your work outside. Get everything ready for yourself in the field. And after that, build your house. Platform engineering is the preparation. It's building the foundation. It's getting everything ready so that when it's time to build, when it's time to ship features, you can do it quickly, safely, efficiently. It's about stewardship too. Good stewardship of your team's time. Good stewardship of your company's resources. You're not wasting developer hours on repeated infrastructure work. They're not burning cloud budget on inefficient duplicate resources. And there's something about excellence here. 1 Corinthians chapter 10, verse 31 says, whether you eat or drink, or whatever you do all to the glory of God. Building a platform is about enabling excellence, making it easy for your teams to do the right thing, to build secure software, to build observable software, to build reliable software. You're creating an environment where excellence is the default path. All right, let's bring this home. Platform engineering is the evolution of DevOps. You're building internal developer platforms, self-service infrastructure, golden paths that make the right way the easy way. Start small. One golden path, one pilot team. Iterate, expand. This is a journey, not a destination. Involve your users. Build with them, not for them. Developer satisfaction is your North Star metric. And always be thinking, is this toil? Should I automate this? Can I build this into the platform so no one ever has to do it manually again? Platform engineering enables everything else we've been talking about in this series. It makes Kubernetes practical. It makes multi-cloud manageable. And it sets up perfectly for what's coming next. Next week, episode 9, we're diving into observability and monitoring. How you actually see what's happening in your systems across multi-cloud. Prometheus, Grafana, distributed tracing, the whole stack. Then we'll cover CI/CD pipeline security, how you secure your software supply chain, S-bombs, artifact signing, the works. Then we'll bring it all together with zero trust architecture. That's the arc we're building towards over the next few weeks. If you want to go deeper on this stuff, check out my Medium, that 12-part series, Crafting the Modern IT Ecosystem, parts 3 and 4 and 11 especially. And also that DevSec automation article about making CI/CD pipelines your safety net. All the links are in the show note. Check out DevSecOpsWithScott.com. I was not great about getting those articles out for a while. I was focused more on Medium, but I'm trying to give some balance here and do more on my own blog. Here's your action plan for this week. 1, identify one manual process in your workflow that you can automate. Just one. 2, talk to your developers. Ask them, what's causing you the most friction? What's taking the most time? 3, research developer platforms. Check out Backstage from Spotify. Check out Port. See what's out there. 4, start thinking about your golden paths. What's the most common things your teams deploy? What's your first golden path? 5, read the series. Part 4 is all about platform engineering. It'll give you a full picture. Platform engineering is how you scale DevOps, DevSecOps, and SRE practices across your entire organization. It's how you go from one team being efficient to hundreds of teams being effective. This is Scott Houghton reminding you that the best platforms make excellence easy. Until next time, keep building, keep believing, and remember, if you're doing it manually more than twice, it's time to automate. God bless. I hope you enjoyed this episode of Faith, Freedom, and Tech. If you did, like, subscribe, and leave a review. It helps others find us. Share this episode with your infrastructure team, your DevOps team, your platform engineers, someone who needs to hear that there's a better way. Find me on X at faithft_podcast or everywhere else at Faith Freedom Tech. Check out faithfreedomtech.com for show notes, transcripts, and those Medium article links. Keep building, keep believing, and God bless.